Hello students, so welcome back to the channel. So in this video you're going to be handling the third tutorial about trigonometry. So in this video we are going to be looking at Pythagoras theorem to derive our first three trig identities. So in this video we are going to be looking at verification of the first three trig identities. We look at how we can prove them. We look at how we can use them to simplify equations and also to use them to solve different types of items or tasks. So this video is presented to by Olgan Baisuf. You are advised to like the video and then share the video to your colleagues so that you can all benefit and pass as a team. So when you're looking at the first three trig identities, we are going to see that all the first three trig identities, they are going to be derived from Pythagoras theorem. And you're going to say that consider a right angle triangle. Since every Pythagoras theorem, we consider always right angle triangles. So you're going to consider a right angle triangle with an angle which is going to be theta, and then y is going to be equal to sine theta. Y is always going to be sine theta, and x is going to represent cos theta. Then our hypotenuse side is going to represent 1. Now in the previous video, or the first video, we saw how y I'm calling y to be cos sine theta and y I'm calling x to be cos theta. We derived that in the first video. So now let's proceed. Let's see how we can use this right angle triangle. Now according to Pythagoras theorem tells you that if you get y squared and then you add it to x squared, we are going to get 1 squared. Or if you add the squares of the opposite and the adjacent, you're always going to get the square of the hypotenuse. So we are simply going to substitute for y, whereby y is the same as sine theta, and then x is going to be the same as cos theta. So according to what you have explained, according to the above triangle, according to Pythagoras theorem, you see that x squared plus y squared is going to be equal to the hypotenuse side, which is squared. So 1 squared is the same as 1. So after that, we identify y and x, and then we substitute for it. So it's going to become cos theta squared and then sine theta squared to be equal to 1. So if we enter the squares inside, we read it as cos squared theta then plus sine squared theta to be equal to 1. Now this is the main equation from which we derive the other two identities. So remember that there are three identities. So the first one is cos squared theta plus sine squared theta to be equal to 1. And then the second one, we are going to either divide through by sine squared theta to get the second one, or divide through by cos squared theta to get the third identity. So let's start by dividing through by cos squared theta so that we can get our second identity. So if we get the first identity and then we divide throughout by cos squared theta, this cos squared and the cos squared will go and then we get 1. And then sine squared theta divided by cos squared theta is the same as tan squared theta. And then 1 divided by cos squared theta, in the previous video we said that reciprocal of cos is sec. So 1 plus sine squared theta is going to be the same as sec squared theta. Now this is going to be our identity number 2. So let's start from the first identity. We can either make cos squared the subject. So if you make cos squared theta the subject, you're going to get 1 minus sine squared theta. And then if you make sine squared theta the subject, you simply take cos squared theta the other side. You're going to attain 1 minus cos squared theta. Now proceeding, if we come back to the initial equation and we divide through by sine squared theta, we are going to get our third identity. And this is going to be cot squared theta plus 1 to be equal to cosec squared theta. Now we are going to make a note that these identities, we are going to be using them to transform different trigonometric expressions into different forms. Now here this is going to involve both proving, simplifying together with solving, which is going to be the rest of the video or tutorial. Now let's start here. You always have to remember the main equation, which is cos squared theta plus sine squared theta to be equal to positive 1. That's the main equation and you should always remember it at all times. because the one that we use this standard identity to get or to derive the other identities. Like I said, the second identity, we get it by dividing through by cos squared theta. And then the third identity, we get it by dividing through by sine squared theta. And then you're going to end up with your three identities. So simplifying together with proving is going to involve making either of them in the identity the subject. Like we did here, if we make cos squared theta the subject, it's going to be the same as 1 minus sine squared theta. And then if you make sine squared theta the subject, it's going to be the same as 1 minus cos squared theta. So you're going to be repeating that process in the next worked examples. So looking at the following worked examples, so question 1 or item 1, you're going to prove the following identities. So we are going to prove that sec theta minus cos theta is going to be the same as sine theta being times tan theta. Now notice that when you're dealing with proving, we always pick one side, and in most cases we are going to go with our left hand side, and then we calculate it or we simplify it to see whether our final answer is going to be the same as that one which has been given the item. So that's the procedure. You pick one side and then you solve it and you see whether you can get the answer that has been given the item. That's how we prove. So starting with part A, we are going to start with the left hand side. So for part A, sec theta minus cos theta, we are going to be simplifying the left hand side. Now notice that when you're simplifying or when you're proving, you have to convert everything in terms of cos theta or sine theta. That's the first thing. So after everything has been converted to cos theta or sine theta, in case you're having fractions, always make sure that you correct or you find LCM. And after that, the next thing is going to be to simplify until you reach your proof. So all the proofs are going to follow the same procedure. 1, make sure that you convert each and everything in terms of cos theta or sine theta. And then 2, you make sure that if you're having a fraction, you find LCM as the next thing. And then thirdly, we are going to simplify until we reach to the required proof in the question. So if you look at part A, we're having sec theta minus cos theta. So sec theta, we can easily convert it into either sine theta or cos theta. But sec theta is the same as the reciprocal of cos. And then cos theta, since it's already cos theta, we don't alter it. So now you notice that we are having a fraction right now. So to simplify this, we have to collect LCM since we are having a fraction. So when you collect LCM, the LCM is going to be cos theta. And in the numerator, we are going to end up with 1 minus cos squared theta. But remember the first identity. In the first identity, we told you that cos squared theta, then my plus sine squared theta is the same as 1. So here, if you make sine squared theta the subject, and you take cos squared theta this side, over the equal sign is going to be sine squared theta is going to be the same as 1 minus sine squared theta is going to be the same as 1 minus cos squared theta, which we are having here in the numerator. So what you do, instead of 1 minus cos squared theta, we substitute it with sine squared theta from the first identity that you looked at. So now our solution becomes sine squared theta divided by cos squared theta. Now if you look here, you go back and you look at your proof. So if you look at the proof that you're trying to prove, we are having sine theta multiplying tan theta. So what you're going to do is that you're going to separate our numerator. When you separate one sine from this sine squared, you're going to remain with sine theta divided by cos theta. And remember, sine theta divided by cos theta is the same as tan. So we shall end up with our proof to be sine theta tan theta. And then you make a conclusion that hence proved, since the left hand side is equal to the right hand side. So now we are going to proceed calculating the same way, part B, part C, part D, and part E. First, we have to convert everything in terms of sine and cos. Then later, if you're having fractions, we correct LCM. After that, we simplify to get the right hand side. So we are going to be basically repeating the same procedure. So looking at part B, we are basically going to repeat the same procedure. So first we are going to start with the left-hand side, and then we try to prove, or we try to work it out or to simplify it, and we get the right-hand side in the question. So what we say that we start by simplifying everything in terms of cos and sine. After that, if you have fractions, you find LCM, and after that you simplify to get what is in the question. So cot theta is the same as 1 out of tan, always the reciprocal of tan. But remember that this is the same as 1 divided by cos theta. Tan is going to be the same as sin theta divided by cos theta. So if you find reciprocal, this is what happens. We get cos theta divided by sin theta, and then tan theta is the same as sin theta divided by cos theta. So since we're having two fractions, we are going to find LCM, and LCM is going to be the product of what we're having in the denominator. So LCM is going to be sin theta cos theta. And then when you do that, in the numerator, we are going to end up with cos squared theta plus sin squared theta. But remember, in the first identity, we told you that cos squared theta plus sin squared theta is the same as 1. So you're going to replace our numerator with 1, and then you're going to end up with this. So from there, we prove what was given in the question. So we're going to separate either of them. So it's going to be the same as, this one is going to be the same as 1 out of sin theta, then times 1 out of cos theta. But remember, reciprocal of sin theta is the same as cosec theta, and then reciprocal of cos theta is the same as sec theta. So we rearrange it according to the question requirements, and then we get what was given on the right hand side. So from there you make your conclusion, hence proved. So part C, we are going to also repeat the same process. So if you look at part C, we are going to start from our left hand side. So you're going to say that 1 plus sin squared theta is going to be the same into cos squared theta. So here we are not going to simplify anything like tan and cos, simply because we are having an identity which can be fooled. Remember that we got this in the second identity. So 1 plus sin squared theta, according to the second identity, is the same as sec squared theta. So we substitute for it, and then we multiply it to cos squared theta. So after that, we make everything in terms of sin and cos. So remember that sec squared theta or sec theta is the same as 1 out of cos squared theta. So sec squared theta is going to be the same as 1 divided by cos squared theta. So if we try to simplify it with this, cos squared theta and cos squared theta are going to cross or cancel each other, and then we end up with 1. And that was what was required in the item. So if you look at part D, we are going to be proving starting from the left hand side. So here we have nothing to simplify in terms of sin and cos because the left hand side was already simplified. So we start by opening up the brackets. So when you open up the brackets, you're going to end up with cos squared theta, then plus sin squared theta, then plus 2 sin theta cos theta. So we are going to collect like terms, both cos squared theta, and then we add it to sin squared theta, so that we can get the first trig identity. But remember that we say that cos squared theta plus sin squared theta is the same as 1. So you're going to end up with 1 plus 2 sin theta cos theta, which was required. So for part E, we are going to basically repeat the same procedure. Since here we're having a bracket of sin theta plus cos theta on our left hand side being multiplied with tan theta cot theta. So we are having expressions that are not in terms of sin and cos. So we start by simplifying that bracket. So if you get that bracket, you're going to have sin theta. Tan theta is the same as sin theta divided by cos theta. But cot theta is the reciprocal of tan. And remember that tan is the same as sin theta over cos theta. But since cot theta is the reciprocal of tan, then we change everything. So it's going to become cos theta divided by sin theta. So from this step, since we're having fractions, we find what we call the LCM. And it's going to be the product of what you're having in the denominator. So cos theta multiplied by sin theta. And then you end up with sin squared theta plus cos squared theta in the numerator. So remember that what you have in the numerator is the full identity. So the summation of cos squared theta and sin squared theta is the same as the first trig identity, which equates to 1. So after that, we are going to insert or multiply the numerator, and then we divide it by our denominator. So once we do that, you're going to end up with this. Now from there, we look at the question, and then now remember that here, this is like correcting LCM, so we split back our fraction. We looked at this in the first videos under pure mathematics. So we split back this before getting the LCM. So it's going to be sin theta, the first one divided by the denominator. Also the second one divided by the denominator. So we end up with two components. So from here we can simplify them. Sin theta cancels with sin theta, and then we end up with 1 divided by cos squared cos theta. And then cos theta cancels cos theta, and then we end up with 1 divided by sin theta as your second term. But remember that reciprocal of cos is the same as sec theta. Also reciprocal of sin is the same as cosec theta. And that was what was required by the task. So discussing the next item or the next question, we are going to be looking at how you can prove also these identities. So remember, we are going to be following the same principles, but some require to be technical. So if you look at part A, we are going to start from the left-hand side. So once we get our left-hand side, we are going to first separate these two components simply by putting cot theta aside, and then to separate them, it's going to be the same as cot theta times 1 divided by tan theta. But remember that 1 divided by tan theta or reciprocal of tan is the same as cot theta. So you're going to end up with cot theta times cot theta, then plus 1. So cot theta times cot theta is going to give us cot squared theta plus 1. And remember, from the third identity, from the third trig identity that we derived, we saw that cot squared theta plus 1 is going to be the same as, or is going to equate to cosec squared theta. Now, since we have got what is present on the right hand side, we can therefore conclude by saying hence proved. So for part B, we are going to go back to the normal terms that we have been operating on. So first we handle our left hand side, and then later we convert everything in terms of sine and cos. So left hand side, handling left hand side, we first rewrite it. After rewriting it, cos squared, we don't simplify it, but we simplify cot squared theta. So cot squared theta is going to be the same as sin squared theta after simplifying 1 divided by cot squared theta. If you express cot theta in terms of sine and cos, we are going to end up with sin squared theta divided by cos squared theta after simplifying everything. I hope you understand that process by now. So we are going to have 1 divided by cos squared theta minus sin squared theta divided by cos squared theta. So since we're having fractions, we say that once we get fractions, we find LCM. So the LCM for this case is going to be cos squared theta. So remember that they are having the same denominators, so we just have to unify the numerator. So it's going to be 1 minus sin squared theta. But from the first trig identity, you saw that when you make cos squared theta the subject, we end up with what you're having in the numerator right now. So you're going to equate it to cos squared theta since they mean the same thing. So 1 minus sin squared theta is the same as cos squared theta divided by our denominator, which is also cos squared theta. So both of these ones cancel each other, and then we end up with 1, which was required in the proving. So you can make a conclusion and you say that hence proved. Now, since proving is always not from one side, we have been seeing that we have been handling the left hand side. You can also come from the right hand side, going and proving what is present on the left hand side. Depends which one you find easier. So starting from the right hand side, we can say that the right hand side, which is the same as for part C, was the same as 1 divided by 1 plus sin squared theta. But we all know that from the second identity, that 1 plus sin squared theta is equal to sec squared theta. So we come and we substitute for it, showing that sec squared theta has replaced 1 plus sin squared theta, because that's what the second trig identity says. So the square root of sec squared theta, the squares are simply going to terminate each other, and then we end up with 1 divided by sec theta. But remember that sec theta is also the same as 1 over cos theta. So if we simplify everything, we are going to end up with cos theta, which is present on our left hand side. So from this point, we can say hence proved. So for part D, we are also going to start from the right hand side. So you're going to get a tan theta divided by 1 plus tan squared theta. So you have to first separate these two simply by saying that it's going to be the same as tan theta times our denominator in terms of a reciprocal. And then we express everything in terms of sine and cos. But remember that what is under the square root is an identity. So we have to substitute for it. So tan is the same as sine theta divided by cos theta. And then this identity of sec squared theta as replaced 1 plus tan squared theta, because from the second trig identity, we saw that sec squared theta is the same as 1 plus tan squared theta. So when you get the square root of sec squared theta, you're going to end up with 1 divided by sec theta, which you have seen above in the above item, that is the same as cos theta. So you're having sine theta over cos theta times cos theta. So what happens? This cos and this cos cancel each other, and then you end up with sine theta as your final answer, and that's what was required in the proof we are handling. So these are the circumstances, or these are the areas where we are going to be required to prove starting from the right hand side, in case what we are having on the left hand side appears to be unsolvable. So let's look at question 3 very quick, which is going to be the last one in proving the trig identities involving Pythagoras theorem. So this one, you are being provided that sine theta divided by 1 plus cos theta, then plus 1 plus cos theta divided by sine theta is equal to 2 divided by sine theta. So we are supposed to prove that our left hand side is equal to our right hand side. We also do the same for part 2. So let's start with solution number 1. So beginning from the left hand side, we are going to first rewrite it. Then after rewriting, since we are having fractions and everything is in terms of sine and cos, we simply go straight forward to the next step, which was finding LCM. So the LCM is going to be the product of our denominators, sine theta times the bracket of 1 plus cos theta. So we shall end up with this expression. So after finding LCM, we already explained finding LCM in the first videos under pure mathematics. So I hope everyone understands that. So you're going to end up with sine squared theta, then plus the square bracket of 1 plus cos theta in the numerator. So what you have to do, we have to simplify our numerator by opening up this bracket. Always first wait to open up the brackets in the denominator. In other words, never simplify denominators before you simplify numerators. So we have to first simplify numerators alone, and then later we simplify the denominator, but always do not open brackets in the denominator. So when you open up this bracket, it's going to be the same as 1 plus 2 cos theta and then plus cos squared theta. Now remember that we are going to add these two together. We are going to add sine squared theta then plus cos squared theta. And remember that that's the first trig identity. And we say that the summation of cos squared theta and sine squared theta is the same as 1. Then we write the others. So the remaining thing is going to be this one, and then we bring it here. Then plus 2 cos theta. So when you add the 2, we are going to end up with 2 plus 2 cos theta. So since 2 is going to be common, we prime factorize it out, and then we end up with this expression. So according to our expression, you're seeing that it's going to be 2 into bracket of 1 plus cos theta, and then we divide by our denominator, which we didn't simplify, which is the same as 1 plus cos theta into sine theta. So you can see that both of these brackets are common in the numerator and in the denominator. So we cancel them out, and then we remain with 2 divided by sine theta, which was required in the proof. So you can make a conclusion that therefore hence proved. Or you can simply say, since left hand side is equal to right hand side in the question, the proof has been completed. So looking at part 2, we also under the left hand side. So first we start by rewriting our left hand side, which is the same as tan squared a minus sin squared a. So here we have to first start by converting tan in terms of sine and cos. After that we find LCM, after that we simplify. It's as simple as that. So tan is the same as sin squared a divided by cos squared a. Then after that, since we're having a fraction, we have to find LCM, and LCM is going to be cos squared a. So in the numerator, we are going to have sin squared a minus sin squared a cos squared a. So from here, since sin squared a is common in the numerator, we prime factorize it out on both of the terms. So we are going to end up with sin squared a into 1 minus cos squared a divided by cos squared a. But remember that this expression right here comes from the first trig identity when you make sin squared a the subject. So if you make sin squared a the subject in the first trig identity, you end up with 1 minus cos squared a. So we substitute for this bracket with sin squared a. So we shall end up with sin squared a multiplying sin squared a. And after having that, sin squared a times sin squared a, the powers sum up each other since we are dealing with multiplication according to indices. And then we end up with sin power for a, then divided by our denominator, which is the same as cos squared a. So we can simplify this by separating our numerator, and then we multiply it with 1 divided by cos squared a. But remember that 1 divided by cos is the same as sec. So this is going to be the same as sin power for a multiplying sec squared a as your final answer. So that was it for the proof. Now the next part you're going to get is going to be solutions to equations that involve use of Pythagoras theorem of the first three trig identities. So now here you're going to know that you are going to require, or you are going to need to borrow knowledge from the previous video of finding angles given the range. We saw from the previous video how we can find angles. So for this we are going to do it very fast. Very fast. So make sure that you are very conversant with the second video about finding angles. The other part is just going to be easy because it's going to simply mean simplification. So if you start with part A, if you go to part A, you saw that they gave us 2 sin theta to be equal to tan theta. So what you're going to do, we convert tan theta in terms of sine and cos. And then we end up with 2 sin theta to be equal to sin theta divided by cos theta. So since we're having a fraction here, we make our equation linear simply by cross multiplying. So if you cross multiply, you're going to end up with 2 sin theta cos theta to be the same as sin theta. But here, now majority of you will be missing out scores on this step. So when you reach here, you make sure that you do not divide trig expressions. Do not ever divide trig expressions. So what we do, we bring the other trig expression onto this side. We don't divide through by sin theta, but rather we bring it onto one side. So we bring the sin theta back onto our left hand side. And if you do that, you're going to end up with 2 sin theta cos theta then minus sin theta to be equal to 0. So if you look at this equation, you are seeing that sin theta is common on this term and is also common on this term. So what you do is that you're going to prime factorize it out. So once we do that, so these two are not supposed to come out inclusive. Once you do that, you're going to end up with sin theta into 2 cos theta, then minus 1 to be the same as 0. I hope that is understood. You simply prime factorize out what is common. So you end up with sin theta into 2 cos theta, then minus 1 to be equal to 0. So now to get the angle, we are going to say that either sin theta is going to be equal to 0 or 2 cos theta minus 1 is going to be equal to 0. And then we see how the different angles are going to be attained. So I've noticed that there was a misrearrangement in the calculation of the angles due to the error that we made in the previous slide that I've just corrected. So what you're going to do is that you are going to move with the other slide and then you find the corresponding angles. since we have already explained that in details according to the previous tutorial or the previous lesson. So what I'm going to do, I'm just going to go with this one. So one, we are going to go with sine theta to be equal to 0. Either sine theta is equal to 0, or this was supposed to be 2 cos squared theta minus 1 is equal to 0. But rather, for me, let's go with this one. For you, you go with the right one. And you make sure you get the right angles according to what we discussed in the previous lesson about finding angles. So for this, sine theta is equal to 0. So remember that we told you that in the previous video, whenever sine theta is equal to 0, we expect 3 angles, and that is going to be 0 degrees, 180 degrees, and also 160 degrees. Then for this case, cos theta is equal to 1. So to get the angles, first you have to first take cos this side. So this one, since the expression of cos is positive, that means that you are getting the angle from regions where cos is going to be positive. So one is going to be coming from the first quadrant, and then the other one is going to be coming from the fourth quadrant, because it's these two regions where cos is going to be positive. So getting theta is going to be equal to arc cos. You make sure that you indicate that step, arc cos of 1. So once we get the arc cos of 1, we'll end up with the first angle to be 0 degrees. So since the first angle in the first quadrant is 0 degrees, to get the angle in the fourth quadrant, we say that this is going to be 360 minus theta. So our theta is 0. So 360 minus 0, you're going to end up with your second angle to be 360 degrees. So after that, we make a general conclusion that therefore theta for this range is going to be equal to, you correct all angles and then you arrange them in ascending order. So it's going to be 0 degrees, 180 degrees, and also 360 degrees. Now let's look at the other items that are going to involve what you have just covered, the first 3 trig identities. Now to solve that, we need to be very careful. So first you need to identify the trig identity with a squared component on it, and that's going to be the identity that we need to substitute for with the trig identities. So first we write our question. Our question or item was 8 sine theta to be equal to 3 cos squared theta. But remember that from the first trig identity, cos squared theta is the same as 1 minus sine squared theta. Why are we converting it to that? Because we want our equation to be uniform in terms of sign. And to do that, you always have to find the one which is always squared. Is the one that you're supposed to substitute for, simply because all the first trig identities we are dealing with have trig functions that are squared. So in the bracket, you're going to have 1 minus sine squared theta. So we have to first open up this bracket. If you open up the bracket, 3 multiplies 1 and we get 3. And then 3 times negative sine squared theta, we are going to end up with negative 3 sine squared theta. So from this, since we're having sine squared theta and sine theta, we are going to end up with a quadratic equation. So we have to equate our equation to 0 simply by bringing everything onto the left-hand side. So once we do that, you're going to end up with 3 sine squared theta, then plus 8 sine theta, then minus 3 to be equal to 0. So we are going to let our sine theta to be any unknown. So we are going to say let x be equal to sine theta, so that we end up with a quadratic equation in the format 3x squared plus 8x minus 3 to be equal to 0. So for this, you are free to use any method of your choice, basing on what we have already covered. We looked at factorization method, quadratic formula, or what you call the bulldozer, which I'm going to be using for this lesson. And then we also looked at the other method, which is completing squares. So use the one which you are very well versed with. On using the quadratic formula, I already explained to you how to appropriately use the quadratic formula, so I will not be reviewing that. So using the quadratic formula, one of the x values we are going to get a third, and the other x value we are going to get negative 3. But remember, we are not interested in the x simply because x is the same as sine theta. So we want to get the angles when sine theta is the same as a third, and also when sine theta is the same as negative 3. Now starting with sine theta equals to a third. Now this is a lesson from the previous lesson, which was finding angles. So here the expression of sine is positive. So what you have to do is that you have to identify the angles of theta in the positive regions where sine is positive. And it's going to be the first quadrant. The first quadrant gives us theta, and then the second quadrant is for the quadrant where sine is positive. So you have to get the angle. We measure them starting from the positive x-axis. One is going to come from there to that, and then the other one is going to come from there to that. So getting theta for this, for sine theta to be equal to a third, theta 1 is going to be 19.47. But I told you, you need to show that theta is going to be the same as arc sine. So I didn't include this for this lesson, but you make sure that you indicate it, because it's a step that has to be shown. So theta is going to be obtained as arc sine of a third, and then we get our theta, or our value of the angle, to be 19.47 degrees. And then to get the other angle, is going to be getting angle in the second quadrant is 180 minus theta. So 180 minus 19.47, we are going to end up with 160.53 degrees. So that was it for a third. Then what about when sine theta is equal to negative 3? Now remember the graphs that we drew in the previous video. We told you that any value of sine or cos should not exceed the ranges of -1 to +1. And then we say that if you're having any expression of sine or cos beyond that range, beyond -1, like this, like -3, or beyond +1, we say that that angle is going to be undefined, because if you put it even in your calculator, the calculator is going to tell you either math error or syntax error. So you simply say that the angle is undefined, and then you make a conclusion that therefore for theta to lie between 0 degrees and 360 degrees, the value of theta is going to be 19.47 and also 160.53 degrees. I hope that has been understood. And if you're having inquiries, you make sure that you address your issues in the comment section. I'll be replying to them. You like the video if you are benefiting from it, and share it to your colleagues in case you haven't yet received it. So let's go to part C. Part C, we are going to first write our question, and then the value with the squared for this time was sine. So from the first identity, we saw that sine squared theta, if you make it the subject, is going to be the same as 1 minus cos squared theta. So we have to replace it for that. After that, we open up brackets. After that, we equate our equation to 0 by bringing everything onto the left-hand side, just like we did previously. And then we shall end up with our quadratic equation. Then you have to let x to be our trigonometric expression of cos. When you do that, you shall end up with a quadratic equation. So you're going to use the quadratic formula to find the two values of x. And one value is going to be equal to a half, then the other value is going to be equal to -2. Now if you look at -2 according to our graph of +1 and also -1, -2 is out of the range. So for this value of x, or for this value of cos theta, we shall say that the value for this angle is undefined. But since a half is within the range, then for it you are going to get the corresponding angles for it. So for cos theta being equal to a half, so first you can see that the expression of cos is positive. That means that you are getting your angle from regions where cos is positive, according to the previous lesson, which was about finding angles. So one is going to be coming from the first quadrant, and the other one is going to be coming from the fourth quadrant, because these are the regions where cos is positive. So to get theta is going to be arc cos over half. So as to get arc cos over half, the first theta is going to be 60 degrees. So to get the angle in this third region is going to be 360 minus 60 degrees, and then we get 300 degrees. Now for cos theta to be equal to -2, like we said, for this case our angle is going to be undefined. So make a conclusion listing only the angles that are known. And you're going to say that therefore for the range of 0 degrees, or for the range of theta lying between 0 degrees and 360 degrees, theta is going to be the same as 60 degrees together with 300 degrees. And that was what was required. Now going to part D. First we have to write the equation. So since it's cos which carries a square, we have to substitute for it using the first trig identity. So cos squared theta is the same as 1 minus sin squared theta. So we open up the brackets and then we equate our equation to 0 by bringing everything. Now since we always want the coefficient of the trig identity carrying a squared to be positive. That's why for this time, to convert -4 into positive, we brought it this side. It shouldn't be a negative coefficient, it always has to be a positive. If it's not positive, we divide through by -1. So once we do that, our quadratic is going to be of the following format. So we let x to be equal to our sine theta, and then you shall end up with 4x squared minus x minus 3. So we solve it using the quadratic formula, and then the value of x, the first value is going to be 1, and then the other value is going to be -3/4. Now both of them are valid, so we have to get the corresponding angles for them. Now starting with the first expression for sine theta to be equal to +1, since the expression of sine is positive, that means that we are getting our angle from regions where sine is positive, and that's going to be the first quadrant, and then the other angle is going to be coming from the second quadrant. So one of them is going to be theta, and then the other one is going to be 180 minus theta. So when you get arc sine of 1, you're going to get 90 degrees. And if you try to find the other angle, 180 minus 90 is also going to remain 90. So for that case, since we get two angles and they are the same, we just write 1. We just say 90 degrees. And then for this one, for the sine theta to be equal to -3/4, now here they are trying to tell you that for this expression, sine is negative. Like we explained in the previous video, we don't need the negative. The negative is just trying to show us where we are going to pick our angle. So when you're getting your theta, you simply say that theta is going to be equal to arc sine of 3/4. So we get the angle from regions where sine is negative, and that's going to be the third quadrant together with the fourth quadrant. We measure from the positive x-axis. So the first angle is going to be that, and then the second angle is going to be that. But you have to first get the angle in the first quadrant, though we don't need it. So the angle in the first quadrant, we get it. After that, we get 180 plus our angle to get this angle. And then you also get the fourth quadrant by saying 360 minus theta to get the angle in the fourth quadrant. Then after that, we make a conclusion that therefore, for theta to lie between 0 degrees and 360 degrees, our values of theta or our angles are going to be 90 degrees, 228.59 degrees, and also 311.41 degrees. And that was what was required. So let's go a bit advanced because we have been specifically looking at the first trig identity. So now let's engage in the other remaining two trig identities. And that's going to involve question 2. So question 2, we are being provided the tasks 3 cot theta plus 2 sin theta to be equal to 0, and then 2 cot squared theta plus 11 to be equal to 9 cosec theta, and then sec squared theta minus 3 tan squared theta to be equal to -1, and then lastly cot squared theta plus cosec squared theta to be equal to +4. So for part A, we simplify that simply by, since we don't have any squared component, you simply convert everything in terms of sine and cos. After that, you find LCM and then you make everything linear and then you simplify. So for part A, we are going to handle it that way. Since we don't have any component which is squared, we only substitute for trig identities when you're having a squared component. So for this case, we are going to have 3 cot theta then plus 2 sin theta to be equal to 0. But cot theta is the same as reciprocal of tan, which is the same as 3 cos theta divided by sin theta then plus 2 sin theta to be equal to 0. Now for this case, the LCM is going to be sin theta. So remember that we said that when you're having an equal sign and you get LCM, you have to multiply throughout by each and every value by that particular LCM. So once you do that, you're going to have sin theta times the first value, then to get this. Then sin theta times the second value, you're going to get this. Then sin theta times 0, you're going to get this. So once you simplify, sin theta will cross, and then you end up with 3 cos theta then 2 sine theta times sine theta, you're going to end up with sine squared theta. Then 0 times sine theta, you're going to end up with 0. Now for this case, you notice that we have a trig identity which is having a squared component on it, which is sine squared theta. And therefore we have to use the first trig identity to substitute for it. Now if you use the first trig identity to substitute for sine squared theta, it's going to be the same as 1 minus cos squared theta. So since we have already explained this, let's be very quick. So we substitute for that, and then we open up the brackets. We substitute for cos to be the same as x. We get our quadratic. Ensuring that the coefficient of this one is positive, we are going to take our quadratic onto the other side, so that we end up with this quadratic equation after getting the coefficient of x squared to be positive. So after doing that, we substitute into our quadratic formula. So the first value of x is going to be 2, and then the other value is going to be negative half. But if you look at 2, if you look at our graphs, we say that we need ranges between positive 1 and then negative 1. And 2 is exceeding positive 1. So for cos theta to be equal to 2, we are going to say that that angle is going to be undefined. And then for cos theta is equal to negative half, this means that we have to get our angles from regions where cos is negative. So if you look at the regions where cos is negative, it's going to be the second quadrant and the third quadrant. So first you have to get the angle in the first quadrant, which is going to be 60 degrees, but you are not interested in it. We get the angles that you're interested in. So to get the angle in the second quadrant is 180 minus theta, which is 60. And then the first angle is going to be 120 degrees. And then here is going to be 180 plus 60 degrees, and then we get 240 degrees. I hope by now you are very okay with finding angles. That's why I'm rushing at that point, because we made a full video about it, which was the second lesson about this topic. So we make a conclusion that for theta to lie between 0 degrees and 360 degrees, theta is going to be the same as 120 degrees and also 240 degrees. Now looking at other parts, we are going to be involving the same way of calculation, just that you are going to be using the other remaining two trig identities. So for the remaining two trig identities, you saw that 1 plus cot squared theta, which is the third trig identity, is going to be equal to cosec squared theta. So if you make cot squared theta the subject, you are going to take 1 this side. So it's going to be the same as cosec squared theta minus 1. So for this equation, we get the one which has a square and then we substitute for it. So it's going to be cosec squared theta minus 1, then plus 11 to be equal to 9 cosec theta. So we open up our bracket and it's going to be 2 cosec squared theta minus 2 plus 11 to be equal to 9 cosec theta. So we equate our equation to 0 and then we make cosec theta to be an unknown x so that we can end up with a quadratic equation. So for that, we end up with two values of x. So one, x to be 3 and the other one, x to be 3 over 2. But remember that cosec theta is the same as the reciprocal of sine. So 1 out of sine theta is assumed to be equal to 3. So we find reciprocal on either side. When you find reciprocal on either side, you're going to end up with sine theta to be equal to a third. And if you also find reciprocal on this side, you're going to end up with the second value of sine theta to be equal to 2 over 3. Now, two of these values are valid, and both of the expressions are positive. So we are going to find angles where sine theta is positive. So it's going to be the first quadrant and also the second quadrant. So since we have already explained angles, for sine theta equals to a third, we expect you to get the following angles. After that, we make a conclusion arranging all our angles in ascending order. Remember that we said angles must be two decimal places. Now let's look at part C. So for part C, they told us that sec squared theta minus 3 times squared theta is equal to negative 1. So here both of the components have squared components. So we look for one which has an identity. So according to the second identity, we saw that sec squared theta is the same as 1 plus tan squared theta. So you're going to substitute for sec squared theta. Once you do that, you're going to end up with 1 plus tan squared theta, then minus 3 tan squared theta to be equal to negative 1. Once you open up these brackets, you're going to end up with 1 minus 2 tan squared theta to be equal to negative 1. So you're going to collect like terms. We collect figures alone. If we take positive 1 this side, it's going to be negative 1 minus 1 to give us negative 2. So if you divide through by negative 2, we shall end up with tan squared theta to be equal to positive 1. But you're not interested in the squared, so we shall find square root on both sides. Whenever you find square root, we say that you're at a level, we get positive or negative answer. So when you find square root, you're going to end up with tan theta to be equal to positive or negative 1. So you have to find angles when tan theta is equal to positive 1. We also find angles when tan theta is equal to negative 1. So basically for tan theta to be equal to positive 1, that means that we are going to pick our angles from regions where theta is going to be positive. So that's going to be the first quadrant, and then the other one is going to be the third quadrant. So I hope you remember how we got those angles from the previous video. I've already highlighted that. So the first quadrant is going to give you 45 degrees, and then the second quadrant or the third quadrant is going to give you 225 degrees. Now for tan theta equals negative 1, that means that you have to get the angle from regions where tan is going to be negative, and that's going to be the second quadrant together with the fourth quadrant. So to do that, the first angle in the second quadrant is going to be 135 degrees, and also the angle in the fourth quadrant is going to be 315 degrees. Like I said, we explained this elaboratively in the video about finding angles. So you make sure that before you proceed to any further, you are very good at that, because that's what trigonometry is made of. So you make a conclusion that therefore, for the range of theta to lie between 0 degrees and 360 degrees, our theta is going to be the same as 45 degrees, 135 degrees, 225 degrees, and 315 degrees. All angles, we arrange them according to ascending order. So this is going to be the last part, and it's going to be left for you to assess how these angles came about, the substitutions we made, and why we made them, and why we used them, why we placed here positive or negative after finding a square root, and how we got each of these angles, and how we arranged the final answer. So this task was given in 2 methods. So you try to assess it as a student and see whether and test your understanding. Like we said, if you have benefited from this lesson, you make sure that you like the video and share it to your colleagues. So in case your approach was not aligning with the first method, then you try to look through and follow this method. They're all going to give you the same solutions. So you pause the video and then you try to assess it. So that was it for this video. We meet in the next video, which is going to be proceeding with compound angles. So leave your areas of concern in the comment section. I'll be responding to them. So meet in the next lesson.